All right, this may be a fairly short video, I'm not sure. I have set up 3 of the Dozer Linkage GBC modules, and each of these is powered by a different motor. So on the left here we have an official Lego motor, M-size motor. Here, this is just a kind of no-name brand third-party motor I got on eBay. I think it was like 4 of these for like 20 bucks, maybe even less than that. Super cheap. So we're gonna see how these measure up. And then these are the Mould King M-size motor replacements. I wanna say these are about $14. Depending on where you get them, you'll have to look at shipping costs and things like that. And I've set up a little testing apparatus here. This is the POS terminal that I set up in a previous video. And we're using the DACTA Control Lab. So what we've got here is we've got an output to each motor and a rotation sensor on each of the modules. I didn't want to just test these, just a bare motor and sensor. I wanted some kind of load on them. And this is on the main, drive axle. So it's going straight from the motor through the worm gear and then through the rotation sensor here. So let's do some testing and compare these. Okay, so the test program I'm going to get into a little bit later in the video. For now, I'll go ahead and reset the sensors just to make sure it should do that automatically. And what it does is it runs each motor for 10 seconds each. And then these monitors up top are for the actual count from the rotation sensors. And these actually count 16 ticks per full revolution. And then the results are going to be in each box here, and they will be actual RPM readings. So it's kind of an average RPM reading over the course of 10 seconds. The DACTA Control Lab isn't really the best solution for live RPM readings just because there's a bit of a delay. It seems to count all the ticks and everything like that, but as far as the screen actually updating what's happening, there's a bit of lag there. But this is a decent way to test. So I can either test each motor individually, or I can do this, test all motors, and it will go through each test one by one. So let's do that. And you can tell already, these are these cheap eBay motors. Definitely extremely loud compared to the other two. So that's the Mould King. That's nice and quiet. Again, that's a brand new motor. It has very few, not even an hour on it, but definitely very comparable to an official Lego motor. And just to make sure you can see, let's get up front here. So again, these are the raw readings, 1011, 1284, and 1106. And these are the RPM readings. So we got 377, 479, and 412. And again, official Lego motor, cheap eBay motor, and Mould King. And the reason I've set this up in a text box is because we can run the test as many times as we want. So we'll go ahead and run a few times, and then we will compare the findings towards the end. Okay, so I've run 3 tests sequentially, and you can see the readings are actually fairly consistent, at least with the outer 2. I will tell you, this one in the middle, the cheap eBay motor, seems to have the most variance between runs. And it also has a large variance between running in the opposite direction. I will test that in a minute here. But yeah, so we've got 377, 378. That's about right. These motors are supposed to be around 380 RPMs. You can see this middle one here is quite a bit faster. And in my experience, they're lower torque as well, so certain applications may not work well. And then you have the Mould King on the end, and you've only got a difference of 30-ish, 40, maybe 30 to 40 RPM, which isn't that big of a difference. I think for a lot of GBC modules, it's not really going to be that big of a deal. For this one in the middle, I have run some modules on it, and what I would do is use the 9-volt regulator to run it at a slightly lower voltage, maybe the second to the highest setting on the dial. But again, I don't like how loud they are. The price is right, for $4 each, basically is what it comes out to. What I've really done is, like, for these, I will use this with like train switch tracks and things like that, where you just need a ton of motors. If you have 10 switch tracks, you need 10 motors. And as long as you build the mechanism correctly, this motor shouldn't have a problem. And noise isn't going to be an issue because it's only going to be running for a second or two. So overall, I'm kind of pretty impressed with the Mould King replacement M-size motors. Maybe I'm not crazy about the translucency here, but the dark bluish gray kind of works. I didn't even mean for this to happen, but it matches pretty well with the dark bluish gray in this module here. And I could even lean into it if I had more of the darker translucent windows pieces I could have used there, and it maybe would have matched. Maybe use orange, I'm not sure how well that orange matches up with Lego, but it is what it is. So let's look a bit into the methodology here. So we've just got, okay, so here we're going to assign each port. So we've got our 3 rotation sensors here, 3 motors here, and then this is just a sound element there. And just makes different noises. But if you only turn it on for a fraction of a second, then it just gives you a nice doo-doo kind of noise. And then again here, this is the main page. These are text boxes that are being filled out as we go. If you want to manually reset the sensors, you can just, I like to hold it down a little bit, because if you hit it too quick, sometimes it doesn't actually clear all of them. Again, this software is not perfect, very old. I did have a couple crashes just while setting this up, so I made sure to save often for sure. And then each of these just starts test.a, which is basically a subroutine is what we're doing here. And then this just runs them all sequentially, test A, test B, test C. And all of those are in the procedures page. So we have test A. First, we reset the rotation sensor. Wait 10 is 1 second. TTO stands for talk to. It's kind of a weird language. This is based on the Logo language, which was used in schools and a lot, with Lego. The original interface that Lego had was actually 4.5 volt and controlled motors, and it used the Logo language. And I know Seymour Pipert had a big part to play in that. He's a very interesting guy to look into. Okay, so we play the sound for 2, so that's 0.2 of a second. And then we talk to motor A. Set right, we're setting the direction there. And then on for 100 is 10 seconds. And then we're going to talk to RPM A. RPM A is this text box here. So if I click properties, RPM underscore A. So when you talk to it, you can print. ABS stands for absolute. Round is to round the number off. So absolute, what that means is that no matter which direction the rotation sensor turns, it will return a positive result. And then here, angle 5 divided by 16, because it's 16 steps per revolution. And then we're going to multiply it by 6, because our test is for 10 seconds. There are 60 seconds in a minute, obviously. So that gives us our RPM reading. And then it plays the sound sensor when it's done. So for this test B, I'm actually going to, you'll notice this says set left, while the other two say set right. And what we're going to do is change this to right. And then let's run the motor test B again. And I want to do this because this motor seems to do very differently. Do you hear how much it's slowed down? And how it kind of sounds like it's struggling a little bit? That's very strange. So you can see here we have a negative number for the sensor reading now that we're running in reverse. And you can see this RPM reading is actually much lower than the others there. That's just a strange anomaly I found when I was doing these tests. So again, these motors, while they are very cheap, they have limited use cases. I still have tons of use cases for them. Again, train switch tracks, things like that. But for anything else, I will be using official Lego motors, which I only have, I want to say 6 of these. Back in my eBay Bricklink days, I did sell a few of these, and I guess I just decided to hold on to 6. It's fine, but I use a lot of motors nowadays. But yeah, I'm very impressed with the Mould King substitute, and probably will be using them a fair bit in the future. So I hope you guys enjoyed this video. I just wanted to get a little more scientific in trying to compare these motors together. And from here on out, I'm going to have some video of the modules running with balls running through them, so you can kind of compare the motors together. And if you are interested in this POS terminal running Windows XP for these retro kind of projects, I did a full video on that. It was kind of a nightmare, but interesting to watch, I guess. But this is really great to have a portable solution and to be able to use. I've never used the Control Lab downstairs here, so now I have something I can use it with. So this is the end of the commentary, so we will see you guys in the next one.